All right, let's get into a story that's pretty wild. It's about a biotech drug, a real marvel actually, that changed so many lives. But it had this dark side, a really dangerous secret. We're talking about a drug called Epoetin Alfa.
So I want you to imagine something for a second. What if your body just forgot how to make its own blood? I know, it sounds like something out of a sci-fi movie, right? But for millions of people, this is a very real and honestly a devastating reality. It's all because of a condition called anemia.
So, what is anemia really? Well, in the simplest terms, your body just isn't making enough healthy red blood cells. And why does that matter? Because without them, your body is basically starved for oxygen. I mean, think about it. You feel exhausted, weak, just completely unable to function. This was a huge problem, and it desperately needed a solution.
Okay, so to really get how the solution works, we first have to appreciate the body's own system for this. It's really elegant, actually. The best way to think about it, it's like a super efficient factory churning out what you need. And in this factory, your kidneys, they're the managers on the floor. They're constantly monitoring things. The second they sense that oxygen levels are dropping, they send out a crucial work order. It's a hormone called erythropoietin. And this hormone, it makes a beeline for the bone marrow and pretty much says, hey, get to work. We need more red blood cells and we need them now. But what happens when those factory managers, the kidneys, get damaged? What if they just can't send out that signal anymore? For a long time, the only answer was just constant blood transfusions. Imagine that. But then science came along and delivered what was basically a breakthrough in a bottle, and that was Epoetin Alfa.
And what's just so incredible about this stuff is how closely it mimics the real deal. Scientists use this amazing process called recombinant DNA technology, which is basically a fancy way of saying they taught cells how to make this very specific protein. What they ended up with was a synthetic version of our own hormone. It's a near-perfect copy, ready to jump in and take over when the body just can't do the job itself.
So, how does it actually work? Well, it's like it hijacked nature's own assembly line, but in a good way. The drug travels straight to the bone marrow. Once it's there, it latches onto these things called progenitor cells. Think of them as the parent cells for red blood. It basically flips the on switch for production. And just like that, you get this wave of brand new, young red blood cells flooding into the bloodstream where they mature and get to work carrying oxygen. Pretty cool, huh?
And the impact of this, it was nothing short of revolutionary. All of a sudden, patients who were trapped in this endless cycle of blood transfusions had another option. They had a real shot at freedom. And it wasn't just for one thing either. Its uses were incredibly diverse. For someone with chronic kidney disease, this was an absolute lifeline. It just replaced that missing hormone. It was a huge help for cancer patients who were so weakened by chemotherapy. It could support certain HIV patients. It even let people boost their own blood supply before a big surgery. Just amazing.
And you have to understand, this was so much more than just numbers on a lab report. This was a genuine game changer. It meant people have more energy, it meant a better quality of life, it meant being able to do simple, everyday things again. For so many patients, Epoetin Alfa was a straight-up hero. But you know how it goes. Every great story has a twist. And for Epoetin Alfa, that twist was, well, it was dark and it was dangerous. This is the part of the story where our hero reveals a really serious flaw, and it came in the form of something called the FDA's black box warning. So what is a black box warning? You need to know. This is the most serious alert the FDA can put on a drug. It is a massive red flag for doctors and for patients, telling them, hey, pay attention. There are major, potentially life-threatening risks here. So what exactly were these risks? Well, they were severe. Really severe. Studies started piling up showing that the drug could actually increase the risk of death, of heart attacks, of strokes, of dangerous blood clots. And maybe most alarming of all, for some cancer patients, it looked like it could even speed up the growth of their tumors. And here's the thing that researchers finally figured out. It all came down to a classic case of too much of a good thing. See, at first, doctors were trying to get patients' blood counts all the way back up to normal. But what they discovered was that pushing for those really high targets, well, that's what was dramatically increasing the risk of death and all those cardiovascular problems. This discovery, it changed everything. It forced a complete and total rethinking of how to use this incredibly powerful tool. The entire medical community had to learn this new, delicate balancing act. how to get all the benefits of the drug while steering clear of its dangers.
And out of all this came a new guiding principle. It's a simple little mantra, but it's so profound for doctors. Start low and go slow. The goal wasn't about hitting some perfect number anymore. The goal was now all about safety.
Yeah, the whole strategy just flipped. The old goal of getting patients back to normal hemoglobin levels, that was out the window. The new, much safer goal was way more conservative. It was simply this: use the absolute lowest dose you possibly can to keep the patient from needing a blood transfusion. That's it. And they got really specific about this new goal. A target safe zone for hemoglobin was established. The magic numbers were between 10 and 11 grams per deciliter. That very narrow window, that became the absolute key to balancing the drug's incredible benefits against its very, very serious risks. So you see, the story of Epoetin Alfa is so much bigger than just one drug. It's really a powerful lesson about modern medicine itself. It makes us ask a really tough question. How do we decide when a powerful cure is actually worth the risk? It's a reminder that progress in medicine isn't always about chasing perfect numbers on a chart. Sometimes it's about finding the wisest and the safest balance for each and every person.